Okay. This is 27 volt, 33 volt. Okay, now read the question, everything. So this is not 27, it is not 21. If you can recollect, I did one problem similar to this in the regular class. There it was symbols. Here without symbols, here I brought values. So what we know current through the circuit. We know overall. Let me call this is capital R, and let me take this is small r. Any symbols you can take it. So applied VRMS 33 volt. So we know this. The current, okay, we can calculate the current also. So what is the current will be 5 ampere, also 0.2 ampere. Go directly, I'll apply Ohm's law across the resistor. So across the resistor, what we get? VR. So VR should be equal to I into small r. So VR we know it is 12 I into 60. So therefore I equal to 1 by 5, 0.2 ampere. The resistance of the coil, that capital R. I'll change symbol a little bit. Because usually we take that to be symbol, no? So and let me take this is small r. Smaller is what resistance of coil. There's a symbols what it's a standard one. Let me retain that one. Yeah. Okay, I got the current. And what will be the current? As they are in series, the same current should flow, no? The same current should flow. So it's an RL circuit only. So what is the phase of current across this like a 60 ohm? The current should have same phase across the inductor as well as the internal resistance. So current, what happens? Zero phase, I'll assume. That the phase of current, let it be zero. I think these are the some things which you have to take care here. Let's draw the vector diagram. Let's see that in any help from vector diagram. So there's a direction of current. In RL circuit, is it a lag or a lead? RL circuit, it's a lag, no? So therefore the applied voltage should lead. This is what overall the conditions is what I'm putting. What about the drop across the? So we know this VS, we know current, and we know that 27 volt. What is the 27 volt? Is the vector sum of the drop across the coil plus the drop across the resistance. So this is if you break up further. Analyze this much here. So here let's get into all the things. So this will be 27 volt, what we can write it as 27 volt, we can write it as VR square. Now, what is that 27 volt? Will it lag or lead compared to current? Anybody wants to answer? Or shall I write 27 equal to VL plus VR? I think this is the best question what we have to ask us. This 27, shall I write VL plus VR, or is it correct vector sum? It's a vector sum only. No, this 27 volt, will it lag or lead compared to current? Because what is VR? VR is this one. So where do this 27 volt, shall I take it to be here, or should it be here? So this 27 volt, shall I bring it here? So this 27 volt, let me take it. Yeah, the symbol will help us a lot. You have to think, we have to fight with the diagram. Okay, no, one more diagram. Yeah, this will be this drop VR. VR should have phase of I, no? And what about the V capital R? So will I agree this? The angle between VLR and VR. So the phase of current should be the phase of the drop across this resistor, capital R. So this is like a RL circuit. So there's a current, that current will flow here. So this should be a lag circuit. So even this is also lag circuit, I'm showing it in. Okay, now that VLR, where you show here, will it be between VS and I, or should be here? The resultant of these two, VLR and VR. VLR and VR is what? This VS, no? So there the VS will come somewhere here. Agreed? So therefore this VLR, I'm going to show it here. Okay, now somehow I think we are bringing the voltages. So this, this is the relationship between them. So one more. So what is the angle between? This, let me take it, phi. Okay, I think now I'm into the picture. Huh? So what is VS is, you can write it. So this will be VLR square, V capital R square, plus 2 VLR, VR, cos phi. Now look at this. What all we know? We know VS, we know VLR, we know VR also, V capital R. Solving this, we'll get this phase angle. So if I know this phase angle, this is a phase angle of circuit. What is phi? Phi is a phase angle of circuit. After getting this phase angle, can we define the total impedance of circuit? Because now we know current and applied voltage. Then we know total impedance of circuit. So total impedance of circuit, Z is equal to what we can write, Vs into I. Can we write this any other form, the Z? So Z, can I also write like this? capital R we know, Z we know, XL and R are unknown.
Sir, instead of that, after finding cos phi, we can write VR equal to VLR cos phi. From there also we can get, sir. That is easier.
Okay, that one. Cos phi is equal to, no, VLR cos phi. Okay, yeah. VLR cos phi equal to VR.
Small r.
Small r, capital R, no? I think
VLR,
V capital L smaller cos phi should be equal to V capital R, no? You mean to say this one, no?
phi is angle between V capital R and VLR, sir. Yes, sir. From there, that we calculated from this vector addition formula, sir. VLR is vector sum of V small r and V capital L.
Oh, okay. Again, this is again some of those two, no? This is what
Yes,
I'm
sir.
writing here.
From
Yeah.
there we can get directly.
Yeah. That you can get it, no? No need of these things. Huh? Okay, let me. What is your idea? Just tell me. Like, okay, that.
VLR cos phi equal to V small r.
Okay, again, VL. No,
VLR.
VLR cos phi is equal to. Okay, we'll do one thing. I think you're drawing only RL circuit for that one, no?
Only for that second coil and resistance.
Yeah, that one. I'll do one thing. One more vector diagram. I'll draw it. That will be. So it is for this one because the phase angle of VR and VL should be same, no? V capital R and V smaller should be same. Okay, here you're writing VLR. So like this, I'll replace it.
V
VLR
small
value
r
we know
equal
it.
to
Okay,
IR.
we'll get VR. That value of VR, and we know I. This will be much easier. Okay, fine. So smaller VR is equal to I into smaller. So VR we are getting cos phi from here we got it. VLR we know it. Current I also, yeah, it is also known. So we'll get R. Yeah, okay. Some we have to fight with a vector diagrams here only. That impedance one, I think that will be lengthy. Huh? Total impedance we know it.